Picture this. Tucked inside the permanently shadowed craters near the moon's south pole, hidden from sunlight for billions of years, is water. Not a little bit of water. We're talking hundreds of millions of tons of water ice just sitting there, frozen into the lunar soil. And right now, as you're watching this video, space agencies from the US, China, India, and Europe are all quietly racing each other to get to it first. This isn't science fiction. This is happening. And the stakes? They couldn't be higher. Today, we're talking about why a bunch of frozen craters on the moon have basically started a new space race, and what that means for the future of humanity beyond Earth. Okay, so first things first, how do we even know there's water on the moon? For a long time, scientists assumed the moon was bone dry. It's got no atmosphere, it's constantly bombarded by radiation, and the sunlit surface can hit 120 degrees Celsius. Not exactly a great environment for keeping water around. But here's the thing, the moon also has these deep craters near its poles that are in permanent shadow. The sun never reaches them. And in those craters, temperatures can plunge to around minus 180 degrees Celsius. That's colder than Pluto. Scientists started calling them cold traps because anything that falls in, including water ice delivered by comets and asteroids billions of years ago, basically just stays there, frozen forever. We started getting real hints of this back in the 1990s, when NASA's Clementine and Lunar Prospector missions spotted signals that suggested ice might be present. But the big confirmation came in 2009. NASA crashed a spacecraft on purpose into a crater called Cabeus, near the moon's south pole. A trailing spacecraft flew through the debris cloud and detected it. Water vapor. Real, actual water. The crater ejected over 150 kilograms of water ice into space with just a single impact. Since then, more missions have continued to build the case. India's Chandrayaan-1 mission found water molecules on the surface, and later analysis of data from NASA's Sophia Observatory confirmed ice in sunlit areas too. China's lunar missions have been quietly gathering their own data as well. And so the bottom line is that the moon definitely has water. Quite a lot of it. But it's concentrated near the poles, especially the South Pole. Which brings us to the obvious question. Why does that matter so much? Alright, so water on the moon sounds cool. No pun intended. But why is everyone so worked up about it? There are 3 reasons, and they're all massive. Reason 1. Drinking water and life support. If you're going to build a permanent base on the moon, which multiple space agencies are currently planning, you need water. Shipping water from Earth is extremely expensive. We're talking about tens of thousands of dollars per kilogram just to get something into Earth's orbit, and even more to get it to the moon. If you can harvest water right there on the surface, that changes everything about the economics of a moon base. Reason 2. Oxygen. You can split water into hydrogen and oxygen through a process called electrolysis. Oxygen for breathing is huge for long-duration lunar missions where you can't keep resupplying from Earth. Reason 3, and this is a big one, rocket fuel. Hydrogen and oxygen aren't just useful for breathing. They're literally rocket propellant. Some of the most powerful rockets ever built have run on liquid hydrogen and liquid oxygen. So here's what people are starting to realize. If you can harvest lunar water ice and turn it into rocket fuel right there on the moon stops being just a destination. It becomes a waypoint, a launching pad for the rest of the solar system. Mars missions, asteroid mining operations, deep space exploration. All of it becomes dramatically more viable if you can fuel up at the moon instead of dragging everything out of Earth's gravity well. That's why this isn't just some trivial goal. Whoever controls access to that lunar water ice has a massive strategic and economic advantage in the future of space exploration. And that's exactly why the race is on. Let's meet the major players, because this new space race isn't like the last one. NASA and the United States. NASA's Artemis program has the moon's south pole directly in its crosshairs. After returning humans to the moon, which is still a work in progress, NASA's long-term vision includes a permanent lunar presence. The South Pole's water ice is central to all of that planning. NASA has also been working with private partners, companies like SpaceX, Blue Origin, and a whole ecosystem of smaller startups, to develop the technology for in situ resource utilization, which is the fancy term for saying using stuff you find on other worlds instead of bringing it from home. China and the CNSA. China has been on the speed run when it comes to lunar exploration. Their Chang'e missions have been consistently successful, landing rovers, returning lunar samples, and even landing on the far side of the moon, which no one had ever done before. And China has made it very clear. They want a permanent research station near the moon's south pole by the 2030s, too. They're building toward it methodically, mission by mission, and they've been open about the fact that water ice is a priority resource. The relationship between the US and Chinese space programs is, let's say, complicated. There are actual laws in the US restricting NASA from cooperating with the CNSA. So this isn't a friendly competition. There's real tension here. India and ISRO. India's entry into this conversation came in dramatic fashion in 2023, when Chandrayaan-3 became the first spacecraft to successfully land near the moon's south pole, right where the ice is. ISRO has since announced plans for more lunar missions, and India is increasingly positioning itself as a major spacefaring nation. They're also partnering with NASA on future Artemis-related missions, which puts them firmly in the American coalition's corner of this race. Russia. Russia, or the Soviet Union technically, used to dominate space exploration, and they tried to get back in the game with the Luna 25 mission in 2023, also targeting the South Pole. But the mission crashed during its landing attempt, which was a painful setback for Roscosmos. Russia's space program has struggled in recent years due to funding issues, sanctions, and the loss of international partnerships following the invasion of Ukraine. They're still a major player, but a diminished one compared to the Soviet-era glory days. And then there's the wild card, private companies. SpaceX, Blue Origin, Astrobotic, iSpace, and Intuitive Machines. There's an entire ecosystem of commercial companies that are building lunar landers, prospecting technology, and resource extraction systems. The line between national space programs and private companies is blurring fast, especially in the US, thanks to their Commercial Lunar Payload Services program. Some of these companies are openly talking about selling lunar water ice as a commodity one day, which raises some really serious questions. Here's where things get genuinely complicated. The Outer Space Treaty of 1967, which pretty much every spacefaring nation has signed, says that no country can claim sovereignty over the moon or any other celestial body. The moon belongs to everyone, or to no one, depending on how you look at it. But here's the loophole. The treaty doesn't say anything about resources. It doesn't explicitly say you can't extract and sell things from the moon. It just says you can't place a flag and say, "This is ours." The US took advantage of this ambiguity in 2015 with the Commercial Space Launch Competitiveness Act, which basically said American companies can own and sell resources they extract from space. Not the land, not the moon itself, but the stuff they dig up. China and Russia have pushed back on this interpretation, arguing that space resources should be treated as a common heritage of mankind, not something private companies can just take and sell. So right now, there's no clear international legal framework governing who gets to mine the moon. Countries and companies are operating in a legal gray zone, and nobody's really sure what the rules are going to be, or who's going to make them. The Artemis Accords, a set of principles the US put together and invited other nations to sign, are an attempt to start building those norms. Dozens of countries have signed on, but China and Russia have not. This is a slow-motion collision between geopolitics, international law, and the very future of space exploration. And honestly, how it plays out in the next decade or two could shape the trajectory of humanity in space for centuries. So, the moon is hiding hundreds of millions of tons of water ice in its darkest craters. Multiple superpowers are racing to get there. Private companies are drawing up business plans, and the legal framework to govern all of it basically doesn't exist yet. It's messy, it's complicated, and it is genuinely one of the most consequential stories of our time, even if it never seems to make the front page headlines. We're at this extraordinary moment where the decisions made over the next 10 to 20 years could determine whether space becomes a place of cooperation and shared benefit, or whether it becomes the next arena for the kind of rivalries that have sparked tensions between nations. I don't know about you, but I find that equal parts terrifying and deeply exciting. And hey, drop a comment and tell us, do you think the moon's resources should be shared by all of humanity, or is it fair game for whoever gets there first? Thanks for watching. I'll see you in the next one.